Hello friends, in our last video we learned how to factorize the quadratic polynomials, that is by splitting the middle term. I also gave you a simple trick. In this video we will learn how to use factor theorem in factorizing the polynomials. I know you might be wondering why it is important to learn this method as well when we already have two methods. You will understand that by the end of this video. We will be learning this method with the help of an example. So we have to find the factors of the polynomial f of y equal to y squared minus 8y plus 15 with the help of factor theorem. And now from the factor theorem we know that if x minus a is a factor of the polynomial f of x, then f of a is equal to 0. And even the vice versa is also true. That is, if f of a is equal to 0, then x minus a is a factor of the polynomial f of x. So in this method, first we represent the polynomial f of y as product of two factors, that is y minus a and y minus b. And now from this representation we can clearly observe that the constant term is equal to ab, and by comparison the constant term ab will be equal to 15. To find the factors of the polynomial f of y, first we have to find the factors of the constant term, which is 15. Now we know that the factors of 15 are 1, 3, 5 and 15. Also their negatives, since they also exactly divide 50. Now by trial and error we substitute each of these values in the polynomial f of y and see whether it equals 0 or not. So if we substitute 1 in place of y, we get f of 1 equal to 8 and not equal to 0, which implies that y minus 1 is not a factor of the polynomial f of y. Now if we substitute 3 in place of y, we get f of y equals to 0. So from this we can conclude that y minus 3 is a factor of the polynomial f of y. In the same way, we can observe that f of 5 is also equal to 0, which implies that y minus 5 is a factor of the polynomial f of y. So this is how we find the factors of the polynomial using this method. I know you might be thinking that splitting the middle term method was easier as compared to this method. But splitting the middle term method cannot be applied in the polynomials of higher degree, like the cubic polynomials or the fourth degree polynomials. Now let's see how we will make use of this method in finding the factors of the cubic polynomial. So here is a polynomial g of x and we have to find its factors. Splitting the middle term will not work out for this polynomial since it is not a quadratic polynomial and there are 4 terms in this polynomial, which implies that there is no middle term as such. So what will we do now? We will make use of the factor theorem in finding factors of this polynomial. So the first step in finding the factors is to find the factors of the constant term. Here we can clearly see that the constant term of this polynomial is 20. So we have to find the factors of 20. Now the factors of 20 are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10 and finally plus or minus 20. Now the next step is to substitute each of these values in the polynomial and see whether it equals to 0 or not. One thing is very clear, that is we can reject all the positive numbers. Why is it so? For that, you have to observe the coefficients of this polynomial. All the coefficients of this polynomial are positive, which implies that if we substitute a positive number, then the value of g of x will increase, and there is no chance that the value of polynomial will ever be equal to 0. So we will consider only negative factors of 20. First, let's substitute minus 1 in place of x and see whether g of minus 1 is equal to 0 or not. So, substituting minus 1 and calculating g of minus 1, we get g of minus 1 equals to 0. So, from this we can conclude that x minus of minus 1 is a factor of the polynomial g of x, which implies that x plus 1 is a factor of the polynomial g of x. We can stop this process right here and find the remaining factors from what we already know. Since x plus 1 is a factor of the polynomial g of x, we can write g of x equals x plus 1 multiplied by q of x, where q of x is a quadratic polynomial. Since the degree of g of x is 3 and the degree of x plus 1 is 1. Now, from this, how can we find q of x? It's very simple, right? We just have to divide g of x by x plus 1, and that will give us q of x. So, we will divide the polynomial x cubed plus 13x squared plus 32x plus 20 by the linear polynomial x plus 1. Do you remember the division process? If you remember, pause your screen and try to perform this division process. So first, we will write the two expressions in the descending order of their powers, which is already here. Now, we will divide the first terms of both the expressions, which results in x squared. Now we will multiply the divisor, which is x plus 1, by x squared, which is the first term of the quotient, and we will subtract the product from the dividend. After subtracting, we get the remainder as 12x squared plus 32x plus 20. Now, repeating the same process one more time, we get the quotient as 12x and the remainder as 20x plus 20. Now again, we will repeat the same process for one more time, and the quotient will be 20 and the remainder will be 0. So finally, the quotient will be x squared plus 12x plus 20, which is the polynomial q of x. So g of x is equal to x plus 1 multiplied by x squared plus 12x plus 20. Now we know how to factorize the quadratic polynomial x squared plus 12x plus 20 by splitting the middle term. So let's do it. So here is x squared plus 12x plus 20, and we split the middle term as 2x plus 10x. After that, we will take x common from the first two terms and 10 common from the next two terms, and we get x multiplied by x plus 2 plus 10 multiplied by x plus 2. Finally, taking x plus 2 common from both the terms, we get the expression x plus 2 multiplied by x plus 10. Therefore, the polynomial g of x is equal to x plus 1 multiplied by x plus 2 multiplied by x plus 10, which implies that the factors of the polynomial g of x are x plus 1, x plus 2 and x plus 10. Instead of finding only one factor from the factors of the constant term in the polynomial, we could have found all the three factors as well. But this method will turn complicated once the constant term is very large. That is, let's say if the constant term is 1200, then we will have lot of factors and we cannot substitute each and every factor and see whether the polynomial is equal to 0 or not. So that's the reason we only stop when we get one factor. So friends, this is how we factorize a polynomial by using the factor theorem. Unlike our previous methods, this method will help us in factorizing the polynomials of higher degree. But to be good at this method, you must be very good at arithmetic, which you can improve only by practicing. So keep practicing and stay tuned to tutorings. So this is how we find factors of a cubic polynomial using the factor theorem. So first we find the factors of the constant term of the cubic polynomial, and then using those factors we find one factor of the cubic polynomial, and from there we can easily find the remaining two factors of the cubic polynomial.